Hi, Math 3 students. It looks like the ACT that was scheduled for this week has been postponed. So I think that is scheduled for April 7th right now, but I'm sure the high school will let you know if there are any other changes to that. In the meantime, we'll go ahead and continue with our lessons. If you remember right, we were talking about measuring angles in radians instead of degrees. We'll kind of continue down that path today. Angle measure, you're pretty familiar with now. Now, coterminal angles is what we'll focus on today. Terminate, you know, means to end. Co means with. So coterminal means with ending. So these are angles that end in the same spot. So here's our first question right here. What are coterminal angles? Angles that terminate or end in the same location. Draw an example. Well, we can't do that until I give you a little bit more information. So we're going to go ahead and go down here to the bottom, and we're going to talk about drawing some of these angles. Now, what you need to know is the initial vector is always right here on the x-axis in the positive direction. So I'm going to remind myself that that is the initial vector. So whenever we are drawing angles on our coordinate plane, they always begin right there. And then just like our quadrants, go 1, 2, 3, 4. Our angle measure goes in the same direction. So now we've kind of got to think about this in reference to a circle in degrees, since we're measuring 40 degrees. Straight up would look like a right angle, or 90 degrees. Straight across would be a supplementary angle of 180. Add another 90 and we would be at 270. All the way around we would be at 360. So if I want to sketch 40 degrees, I'm not asking you to pull out a protractor and measure this by any stretch of the imagination. But what you should know is if straight up is 90 degrees, halfway is 40, so 40 degrees would be a little less than 40. And as long as you tell me that it's 40 degrees, I believe you. This has further directions that we'll talk about in a second, but right now we're just focusing on drawing the angles given. 400 degrees. You know, full circle would be 360, right? We need to go how much further to get to 400? Oh, it's another 40 degrees. So look at that. Two angles of different measure, but they terminate in the exact same spot. 2/3 pi radians is how we read that. So we need to remember pi radians is how far? Half a circle was pi radians. I only need to go 2/3 pi. So if this whole thing is pi, I'm going to imagine myself dividing this into thirds. And 2/3 pi would be about right there, right? And here's 1/3, 2/3, 3/3. So this right here is my 2/3 pi radians angle. Okay, so back up here to the very beginning. If I'm drawing an example of coterminal angles, here's my coordinate plane. Here is my initial vector. Let's have it end right here in quadrant 2. Another way to get there, and we didn't talk about this in our angles below, these were all positive angles that we measured. So if these are positive directions going in 1, 2, 3, 4, a negative angle would therefore go in the reverse direction. Coterminal angles, they end in the same exact spot. Sorry about that. This one I went in this direction. They end in the exact same spot, but they happen to have different measure. What is a reference angle? A reference angle is the angle measure between the terminal vector and the x-axis. So let's talk about that. If I have an angle with measure, there's 90, let's go another 30. So let's call this angle 120 degrees. Okay, I just said the reference angle is the measure between the terminal vector and the x-axis. Here is my terminal vector. It's where the angle ends. How far is it? We'll use a different color to highlight that. How far is it from that terminal vector to the x-axis? If it's 120 here, we know to get to the other side of the x-axis, it's 180. What's the difference there? Our reference angle is 60 degrees. Okay, can also go in the other direction. Here's our initial vector. Let's have a negative measure of, let's say, negative 135 degrees. Here's 90. How much further do I need to get to 135? 45 degrees. Half of my 90-degree angle, right? There's negative 135. Okay, what is the reference angle? How far from the terminal vector to the x-axis? If this was 135, how much further do you need to go to get to negative 180? That would be negative 145 degrees. Okay. Clockwise rotations have positive or negative. Clockwise is this way. All right, so if I am positive and I'm starting here and going this way around the clock, that would be negative measure. Counterclockwise, going in the opposite direction, would therefore have positive measure. Now the last little piece down here on the bottom, and this will be a little bit of what your homework is based on today, is find a positive and negative coterminal angle, meaning one that ends in the exact same spot, one that is positive, and one that is negative. And so pretty much there's just a little bit of addition or mental rotations on these, whatever you like to think of better. My angle here is 40 degrees. What would happen if I went around another whole circle? Whole circle is how many degrees? 360. 360 plus 40 would make that 400 degrees is a coterminal angle. And what did I do? All I did was add 360. So if adding 360 gives me a coterminal angle, guess what else does? Subtracting 360. So 40 minus 360 would be a negative 320 degrees. I have angles that end in exactly the same spot, coterminal angles. One is positive, one is negative. Let's do it to this one. 400 degrees. Add 360, subtract 360. So in fact, I'll just put plus or minus 360 on that. So adding 360 would get me to 760 degrees. Subtracting 360 though, 400 minus 360 gets me to 40. which is another coterminal angle, but is it, it's another coterminal angle, but is it one that is negative? No. So I need to take away another 360. And we already did that over here. So minus 320 degrees. Okay. Now we're not very good at radians, but the more we practice it, the better we get at it. Okay, if 360 is all the way around in degrees, remind me, how far around is a circle in radians? 2 pi's. So same principle here. Like we added 360 and took away 360, here we will add 2 pi and take away 2 pi. A little bit of fraction adding here. So if I have 2 plus 2/3, 2 times 3 plus 2 would be 8/3 pi radians. All right, now let's take it away. Minus, that would be 1 1/3, 3, 4, 4/3 pi. Is that correct? Nope, I didn't do that right. I need to do it the other way. We need to say 2/3 minus 2, which is negative 1 1/3, negative 4/3 pi. All right, look for your homework on Alex, and remember my office hours are via Zoom. Some of you have been trying to join early, and I won't be there until Monday, Tuesday, Wednesday, Thursday, Friday at 10. Thank you.